What's going on, everybody? Mr. Barry here with a blank slate apparently on my screen. The main point of this video is I kind of want to just go back, take a look at some things. In this particular Nearpod, what we're looking at is the difference between one solution, no solution, and infinite solutions. I'm going to abbreviate that here. One solution, no solutions, and infinite amount of solutions, or we also know that to be all real numbers. So when we're dealing with these equations, up front, maybe, what are we looking for? How would we know, maybe just by looking at the equation, what it is that we're going to get? Now remember, generally speaking, in these problems that involve our variables on both sides of the equation, we want to make sure that we get to a spot where there's going to be a variable, I'll just use a plus sign here, plus a constant is equal to a term with a variable plus another constant. So once we get to that spot right there, we're going to be able to maneuver our terms of the variables on one side and our terms of constants on the other side, and then we should be able to hopefully solve from that spot. When we're trying to figure out, hey, how many solutions are there within a problem, there are some context clues we can use. All right, so if it's a one solution type scenario, we would have two different coefficients. So here what I'm saying is that the letter A and the letter B would be some numbers. They're not the same number, though. All right, so A and B would certainly not be the number 0. And we would know that if A and B were not the same exact number, they obviously aren't the number 0. It doesn't matter what the constants are. So I'm just going to kind of, I don't know. It's going to be some number here and some number here. And it doesn't matter what those numbers are. A and B would have to be different. In order for it to be a no solution problem, you would have to have the same exact coefficient. So I'll use the letter A here. Again, it doesn't matter. It's not the number 0. But I have to have the same exact coefficients here in order to have no solution. Now, since it's no solution, that means that we would have to have a false statement. So the two numbers that are constants on either side of our equation would have to be different numbers. So maybe if I put like let me use the letter C here, and then maybe like the letter D there. So you can take any numbers you want and plug them in for C and D. As long as they're different numbers, we would have a problem where there is no solution when we solve the equation, because we know AX and AX, once we subtract them from both sides, they would go away. C is never going to be equal to D. That's false. Finally, in order to have an equation that would produce an infinite amount of solutions, again, what we're looking for here is to have terms that are the same exact thing, same variable, same coefficient on either side of the equation. This time, however, just using a random number, like let's go ahead and just say, I'll just use C here and C here. That would give us an infinite amount of solutions, because once we subtracted AX minus AX, that would go away, and now we have something that would be like C is equal to C. That's a true statement no matter what. The letter C is always equal to the letter C. I'm using the letter C to represent constant here. So I'm talking in generalities there. That's certainly something